Hi guys, so today we're going to be learning about angles and angle measure. And before we get started with our first example, let's look at some definitions here. Okay. So here in this lesson, you're going to be drawing some angles on a coordinate plane. Okay. So on a coordinate plane, one ray is known as the initial side, and it's along the positive part of the x-axis. And then the other ray that forms the angle is going to be the terminal side. Okay, and it rotates around the center. Okay, an angle that's positioned so that the vertex is at the origin is said to be in standard position. Okay, so this is your initial side, and then wherever it ends up will be the terminal side. The vertex will be at the origin in order to be standard position. Okay, and then what we learned in geometry is that depending on the angle measure, that's which direction we're going. Okay, so for a positive angle measure, you're going to go counterclockwise. So you're going to start from here and then go this way. Okay? A negative angle measure starts same at the initial side, but goes in the opposite direction. It goes clockwise. Okay, so that's a little bit counterintuitive. So positive is counterclockwise, negative is clockwise. Okay? And if you have an angle measure that's more than 360 degrees, it just means that you're going to go around another time, right? So here, an example is 495. So starting here, it's going to go all the way around, and that's 360, and then plus the extra 135 ends here at 495. Okay. Okay. So then let's draw an angle. Okay. So the first one here, it says to draw an angle with a given measure in standard position. This is positive 240 degrees, so that means I'm going to go counterclockwise. Okay, so it goes this way. So I'm going to start here. Okay, I'm going to take my protractor. Okay, and then on my protractor, I'm going to match, sometimes it's a hole or a circle, a dot, or a cross. Okay, so starting here, this is going to be where the vertex is. So since it's standard position, it will be at 0, 0. Okay. And match it up with the axis. Okay. And then here, since this is my initial side, it's pointing here. This will be 0. And then to 240. So then I go and then until I hit 240. So here is 180. Okay. So 180. So 240 minus 180. Is 60 degrees. So once I hit here, it's 180. So then now I have to go another 60. So I'm going to put it here. Now opposite. All right, so all the way around is 180, and then I need 60 more. And that'll be here. Okay, and then so I'm going to just put a dot here for now. And then I just need to connect it to the origin. And connect. And so there you go. All right, so it's from here. Here's my 180 plus the extra 60 to be a 240. Okay. So my angle, let me highlight it, is here and here. Okay. We're going this way. Okay. Then this one is negative 30 degrees. Okay. So since it's negative, that means it's clockwise. So it will go this way. Okay. And since it's going this way, I'm going to match up my protractor to here. Okay. Then it's going to point to this 0 and then go to 30. Okay, so that's here. I'm going to put my pen there to hold that spot. And then I'm going to connect. And there you go. All right, and so this negative 30 is from here to here. Initial side, terminal side. So you see my angle. There you go. So why don't you try CYP 1A and 1B? Do it on a separate sheet of paper. Okay? And then once you're done, just attach it to the Go formula. Okay, you should have gotten something like this for CYP 1A for 450 degrees and something like this for CYP1b negative 110 degrees. If you got that right, you can move on to the example 2. If not, here is your explanation. Okay. So here, 450 degrees, it's positive, so I'm going to go counterclockwise. Okay. And then I saw that this is greater than 360, so that means I'm going to make a whole revolution, a whole circle, okay, and then some more. Right. So to figure out how much more, I did 450 minus 360, which is 90 degrees. Okay. And then so after going all the way around, then measuring the 90 degrees, that's here, right? 0, 90, 180, 270, 360. So then 470 is all the way around and then ending here. Okay. Then negative 110 degrees, because it's negative, I know I'm going clockwise, okay, which means I'm going this way. So putting my protractor this side, initial side pointing at 0, and then going until I hit 110 on that side. So that's why it's here. And then I connect it. That's negative 110 degrees. Okay. So then, before we get to example 2, which is converting, let's take a look here. Okay. So oftentimes when we've talked about measuring angles, we often measure it in degrees, right? And 360 is a whole circle. Okay. However, another unit that you can use to measure angles is known as radian. Okay. And this definition of a radian is based on the concept of a unit circle, which we'll talk later on in this lesson and which you'll have to memorize. Okay. And this unit circle is a circle where the radius is 1 unit long. Okay. The center is at the origin of the coordinate plane. And so 1 radian is the measure of an angle degree in standard position whose ray intercepts an arc of length 1 unit on the unit circle. Okay. So the circumference of any circle is 2 pi r, right? To go all the way around is 2 pi r. And so then 2 pi equals 360 degrees, right? So it's based off of the circumference of a circle, which is 2 pi r, or 2 pi times your radius, right? So all the way around is 360. So 2 pi radians is 360, or 2 pi is 360. Okay. And so to convert it, right, what we're going to do is similar to the dimensional analysis that you started learning all the way in pre-algebra. That's the same thing. You're going to multiply it by that conversion factor. Okay. So if you want to go from radians to degrees, it's going to be degrees over radians because that will cancel out the radians here. Okay. And we do 180 degrees is pi because if 360 is 2 pi, that means 1 pi is only 180 degrees, half of that. Okay. To rewrite it to degrees to radians, from degrees to radians, then you're going to put degrees on the bottom and radians on top. Okay, so let's take a look here. Okay, so here we're going to rewrite it into the other form. Okay, so this is 60 degrees. Okay, and so to convert it from degrees to radians, what I want to do is I'm going to multiply it with the degree conversion on the bottom and the radian, you don't technically have to write the R, but the radians on top. Okay? The reason why is because then this degree here in the numerator will cancel out with the degree in the denominator. Okay? So how do we know what we multiply it by? Well, we don't want to change 60 degrees. We still want it to measure that same amount. Okay? So essentially here we're going to be multiplying by 1. Okay? And so here what we know is 180 degrees equals pi in terms of radians. And so here, even though it looks like I'm multiplying something that isn't 1, this is really 1 because they are equal to each other. Because pi in terms of radians is 180 degrees. So I'm not changing the measure, I'm just changing how it looks. Okay. So then what you'll see is that the degrees cancel each other out. And then you're left with multiplying fractions, you go straight across, so 60 pi in terms of our radians. Okay, again, you don't have to write this R, and 180. Okay, then I'm just going to simplify. 60 over 180 is 1/3, so pi over 3. And I got that by dividing by 60 on both sides. So 60 degrees in terms of radians is pi over 3. Okay? So how about converting it the other way? Okay? So this is in radians. How do I convert it to degrees? So to convert it out of radians, I'm going to put my radians on the bottom and degrees on top. Okay? And again, I don't want to change what this measures to. So I need to multiply by something that's equivalent. Okay? And multiplying by 1 is always itself, right? So multiplying anything by 1 will result in itself. So here, it's 180 degrees equals pi in terms of radians. So anything over itself is 1. So this is multiplying by 1 essentially. Okay. And then we'll simplify. The pi and the pi cancel. The radian and the radian cancel. Right? And then here I can simplify. Okay, so instead of simplifying at the end, I can simplify here. Both 180 and 4 are divisible by 4. 4 divided by 4 is 1. 180 divided by 4 is 45. Then negative 7 times 45 is negative 315. And then the units I'm left with is degrees because the radian and the radian cancel out. There you go. Right. So why don't you try CYP 2A and 2B, and then once you're done, come check your answer. Okay, so for CYP 2A, you should have gotten 19 pi over 18. And for 2B, you should have gotten 67.5 degrees. If you got that right, you can move on to the next example. If not, here is your explanation. Okay. So degrees, to change it into radians, my conversion rate is pi radians equals 180 degrees. And since I want to cancel out the degrees, I'm putting the degree unit on the bottom. Okay, 180 degrees pi. Okay, and then I simplify, the degrees cancel, and 190 and the 180 can simplify. They're both divisible by 10, so 19 and 18. Then multiplying straight across, 19 pi over 1 times 18 is 18. Okay. For 2b, this is radians. So to cancel it out, I need to put the radian conversion on the bottom. So pi here is equal to 180 degrees. Okay. Then I just simplify, so pi and pi cancel, the radians and radian cancel, leaving me with just degrees. And then 180 and 8 are both divisible by 4. 8 divided by 4 is 2. 180 divided by 4 is 45. Then multiplying straight across, 3 times 45 is 135. 2 times 1 is 2. And then 135 divided by 2 is 67.5. And then since all that's left is degrees, that's 67.5 degrees. Okay. The next part of the book talks about the unit circle and memorizing the conversion rate. So we'll talk more about the unit circle in a bit since you're going to have to memorize it. But here is the unit circle in terms of the degrees and its radiant equivalent. Okay, so now let's go to example 3. So example 3 says to find both the degree and the radian measure of the angle through which the hour hand on a clock rotates from 1 p.m. to 3 p.m. Okay. So here, if we think about a clock, from 1 p.m., it looks like this. Here's the 12, and then here's the 1. Okay. At 3 p.m., it looks like this, right? 12 and then 3. Okay. So what we know is that this is 90 degrees. Okay. Right. And then here, since it's divided into 3, that means this is 30 degrees. Pointing at the 2 would be another 30 degrees, and then pointing at the 3 would be another 30 degrees. Okay. So then how it changes is it goes from here to here, which is an equivalent of 60 degrees, right? Because to go from 30 degrees to 90 degrees, that's a difference of 60. And since we're going clockwise, that means it will be negative 60 degrees. Okay. right? Another way we know is to go all the way around is 360, right? And then since there's 12 numbers all the way around, 360 divided by 12 is 30, which is why between each number is 30 degrees. So that's why this is 30, this is 90, that's a difference of 60 degrees. We're going clockwise, so that's why it's negative. Okay? So this is the degree measure, negative 60 degrees. Okay? And then to convert it, since we haven't memorized the unit circle yet, not a big deal. Right? We can just use our conversion rate from before. 180 degrees equals pi in terms of radian. Simplify this, 60, 180 is 1/3, so this will be negative pi over 3. And that is the radian measure. There you go. Okay, so why don't you try CYP3 on your own, and then once you're done, come check your answer. Okay, so for CYP3, you should have gotten 1 hour and 15 minutes. There's many different ways to do it, but this is how I did it. So if you got this right, you can move on to our last example. If not, here is your explanation. Okay. So since radians is a lot harder to imagine in my mind, and even though I know that 2 pi radians is one rotation or one revolution, right? To know exactly what 0.5 pi is, I just decided to change it into degrees. So I converted it into degrees, so 450 degrees. So I noticed that this was bigger than 360, so I did 450 minus 360, which is 90, right? So if you think about it, 360 degrees, so going around the clock once, that's an hour, right? So that's why I wrote here 360. Oh, that's an hour, okay? And after I did 450 minus 360, I'm left with 90 degrees, right? And so if you think about it, if our clock is 360, each quadrant, right, is 90 degrees, and each quadrant represents 15 minutes. So then together, 360 and 90, which is 450, 1 hour, 15 minutes, 1 hour, 15 minutes. And there you go. Okay. So that's how I figured that one out. Okay, so now moving on to example 4, which is finding coterminal angles. Okay? So basically, coterminal angles are two angles in standard positions that have the same terminal side, right? So notice that 405 minus 45 is 360. So 405 and 45 degrees are coterminal angles, right? This is both their initial sides, and this is their terminal side, right? So starting here and ending here is the same as just starting here and stopping there, right? So they're the same. So basically what we can do to find coterminal angles is that we can add or subtract 360 for our degree measures to find other coterminal angles, or if it's in radian, we can add or subtract 2 pi or a multiple of 2 pi. Okay, so example 4, okay? It says to find an angle with a positive measure and an angle with a negative measure that is coterminal with each angle. Okay, so 240, to find one with a positive measure, I'm just going to add 360 degrees, right? Because all that means is I'm going to end at the same place, but I'm just going one extra circle around, okay? You don't have to add 360. You could do 720, which is 360 times 2, or something bigger, as long as it's a multiple of 360. But that just makes it easier. So 240 plus 360 is 600. Okay? And so if I were to draw an angle that's 600 degrees and draw an angle that's 240 degrees, they're the same. Okay, so this is just a possible answer. I could add another 360 and get another one, add another 360, get another one. Okay? So one with a negative measure, instead of adding 360, I'm going to just subtract 360. All right? So 240 minus 360 is negative 120. So same thing, if I graphed an angle with negative 120 degrees, it would be the same as the 240 degrees, same as the 600. It's just whether how many times it goes around or in which direction it goes. Okay? So 9 pi over 4 Okay, this is in radians. Okay, so to find the coterminal one, 360 in terms of radians is 2 pi. So I'm going to change this by adding, oh yeah, I should write drawing. Adding 2 pi. Okay. Remember that when we're doing fractions, we need common denominator. So the common denominator here would be 4. Okay. So to change this, you have a denominator of 4. Multiply top and bottom by 4. So this would be 8 pi over 4. Okay. Then once you have common denominator, the denominator stays the same, and you just need to add the numerator. 9 pi plus 18 pi means I now have 17 pi's. Okay. I could add another 2 pi, add another 2 pi, add another 2 pi. It would still be equivalent in some ways, right? They would still be coterminal with each other, right? Because they have the same initial side and the same terminal. Okay, then one with a negative, I'm going to do 9 pi over 4. Okay, then this time I'm going to subtract 2 pi. Right? So again, I need common denominator, so 9 pi over 4. This common denominator is 4, so times 4 on the bottom too, so then minus 8 pi over 4. And once the denominator is the same, keep the denominator. 9 pi minus 8 pi is 1 pi, so this is pi over 4. Okay. However, I wanted a negative one. Okay, so I'm just going to subtract it again. I'm going to subtract 2 pi again, or I can also, I know I need common denominator. I can subtract 8 pi over 4 one more time. Okay. And then pi minus 8 pi is negative 7 pi over 4. And this is my negative coterminal angle. Okay. So why don't you try CYP 4A and 4B, and once you're done, come check the answer. Okay, so some sample answers for 4A, 375 degrees and negative 345 degrees. For 4B, 7 pi over 4 and negative 9 pi over 4. Okay. The reason why I say they're sample answers, this is one possibility, right? But you can keep adding 360 and still get one that is coterminal, right? So you can add another 360, that would be an acceptable answer also. Or you can continue subtracting 360 and get another possible answer, right? So same thing here, you can add another 2 pi, or you can subtract another 2 pi. Okay, so this is where the book ends for this lesson. However, in this lesson, it introduced to you the unit circle, and then somehow, without ever teaching it to you in the book, by the end of the chapter, it expects you to know the unit circle. Okay, and since some of you guys might be going on to pre-calculus or calculus, and you're going to have it memorized anyways, we're just going to start by memorizing it now. Okay, so here, I'm going to start by filling out the degrees first, and then I'll fill out the radian equivalent, and then I'll start filling out what we call here the ordered pairs for them. Okay, and you'll see how they relate in a bit. Okay, so degrees is pretty easy. Okay, so I start by putting in the quadrants. Right, so one way it's easy to see. Here are my quadrants. Right. Right. So here it starts at 0 degrees, right? And then we know here, use a different pen. Here then is 90 degrees, right? Plus another 90, this will be 180 degrees, right? Which makes sense, half of a circle, okay? And then plus another 90 would be 270 degrees. And then back here, again, is 360 degrees, right? So all the way around. Okay, so that makes it pretty easy. Okay, then, you'll see here, is that it's then split into thirds. Okay, so here, split into thirds. Okay. So this is how I fill out my unit circle if need be. And so I start with the quadrants, so 0, 90, 180, 273, 60. Okay, then I do the thirds, right? So each one, so imagine if this was a clock. Here's 12, here's 1, this would be 2, here's 3, okay? So with each, in between, if this is cut into thirds, okay, a third of 90 is 30, so from 0 here would be 33, right? Plus another 30 would be here at 60, plus another 30 is 90, right? Okay, then plus 30 would be 120, plus another 30 is 150, plus another 30 is 180, okay? And from 180 plus another 30 is 210, plus another 30 is 240, plus another 30 is 270, okay? Then plus another 30 is now 300, plus another 30 is 330, and then plus another 30, I'm back at 360, okay? Okay, then what is the one in between? Okay, so this is half of 90. Okay? This. Okay. So then half of 90 is 45. So that's where this is. This is 45 degrees. Okay, or it's 15 away from each of the orange ones I have here. Okay, so 0 plus 45 is 45, plus another 45 is 90, then 90 plus 45 is 135, okay, plus another 45 is 180, 180 plus 45 is 225, okay. 225 plus 45 is 270, 270 plus 45 is 315, and 315 plus another 45 is 360, right? Or if it's easier, you can just add 15 from the orange or subtract 15 from the orange, right? Because that's how far 45 is from 30 and 60 as well. Okay, so that's how you fill out the degrees part, okay? Right. So it's pretty fast. I'm just doing it once. So if you need another refresher again, I would just rewatch this part of the video. Okay, so now the next part, which is kind of new to us, is this idea of radians, right? Okay. So radians, easy. 0 degrees is also 0 radians, okay? We know that to go all the way around is 2 pi, okay? So that means half of all the way around would just be 1 pi, okay? That makes that part easy. Okay, 0 to 180 is half of that is 90, right? So 0 pi, half of that would be pi halves. So I'm using this line now as a fraction line, okay? So half of pi and 2 pi would be 3 pi halves. And then we get that over 2. Okay, we're good? Okay, next then is pi halves. If we divide it into 3, okay, pi halves, right, because here's pi halves, this is divided into 3 sections, right, for the orange. So pi halves divided by 3 is same as times 1/3. That means each of these orange ones is pi over 6, okay? So that means this is pi over 6, okay? To get to the next one, if I do pi over 6 plus pi over 6, this gives me 2 pi over 6, which simplifies to pi over 3. Okay? So I'm going to fill this first quadrant out first. Right, so this is how it works, right? So 0 to pi halves, it's divided into 3 sections, right, from the orange. Okay? And so a third of pi halves is pi 6, which is why this is pi 6. To get to the next orange, I add another pi 6, which is 2 pi 6, simplifies to pi thirds. Okay, so how do we find out the blue one, right? So the blue one comes from this quadrant dividing it in half, right? So pi over 2, this time I want half of it. This would give me pi over 4. Okay, so this is pi over 4. Right? So another way I kind of memorize it, right? I just think 6, 4, 3, 2, there is no 5. Right? So 6, 4, 3, 2. Okay? Then it's going to pick up, since this one's 3, it's going to be 3 here too, right? Or if you think about it mathematically, you're going to add another pi 6, right? So if you want, one way you can do it is, okay, pi halves plus a pi over 6, which this is 3 pi over 6 plus pi over 6, which is 4 pi over 6, which simplifies to 2 pi over 3, okay? Or, we remember it, it's going to be 3 here, okay? Then it's going to follow this pattern again. It's going to be 4 here. Blurry. Then focus. Then it's going to be, so 6, 4, 3, 2. Then it's going to pick up on this one, 3, 4, and then it's going to be 6 here. And this one's going to be 6 again. It's close here. 6, 4, 3. And since this one's 3, this one here is going to be 3, 3, 4, 6. Okay, so how do we know what number we're going to put on top? Okay, so now all of these is 1 pi. Okay, all of these ones are going to be the denominator minus 1. So 3 minus 1 is 2, so this will be 2 pi. Okay, this one is 4, so 4 minus 1 is 3, so 3 pi. Okay? This one's 6, 6 minus 1 is 5, so 5 pi. Okay? Obviously, why it is this is based off of this, right? Adding the pi over 6 or adding the pi over 4. Okay, but here we're just straight memorizing it, so that way we don't have to do all of this calculation all the time. There you go. Okay. This one, so this one was denominator subtract 1, right? So radians, this was denominator minus 1, right? This one is going to be denominator plus 1. Okay, so since this is 6, 6 plus 1 is 7, so this will be 7 pi over 6. This is 4, so 4 plus 1, 5, so 5 pi over 4. This is 3, 3 plus 1 is 4, so 4 pi over 3. Okay? Then, what is this quadrant, right? So again, we could do all this math to figure out what it is, right? But this shortcut for just memorizing the unit circle is going to be 2 times the denominator minus 1. So 2 times your denominator minus 1. Okay? So 3 times 2 is 6. 6 minus 1 is 5. So 5 pi over 3. Okay? 4 is your denominator. 2 times 4 is 8. 8 minus 1 is 7 pi. Okay? Here's 6. 6 times 2 is 12. 12 minus 1 is 11. So this is 11 pi over 6. Okay? And so now we have the conversion of our degrees to radians. Degrees, radians, degrees, radians, degrees, radians, and it's equivalent. Okay? So there you go. Okay. So now let's talk about this. Okay? Looks like an ordered pair. It is. Okay? So earlier in the book, it talked about why we call this a unit circle. And that's because the radius is 1 unit. Okay? So the distance from here to here is 1. The distance from here to here is 1, etc., etc., etc. Okay? So this then is is 1 comma 0, right? X is 1 comma 0. Okay? At this point, if this was 1 away, this would be 1 comma 0. Okay? This then would be 0 comma 1. Right? This one going this way, negative towards my X, will be negative 1 comma 0. And this one going downwards here would be 0 comma negative 1. Okay? Okay. Okay, then the next part of how we get these ones, it actually comes from our 30, 60, 90 triangle and our 45, 45, 90 triangle. Okay, so here is your explanation why. Okay, so basically how our triangles originated. Okay, so originally our 30, 60, 90 triangle comes from an equilateral triangle, right? Which means that these are all the same. Okay? Okay? Right? And this is originally, if it's equilateral, 60 degrees, 60 degrees, 60 degrees. Okay. Then, basically, what happened is we split it right down the middle. Okay? And that gave us this triangle. Okay? This became 90 degrees. This 60 got split in half, so now it's a 30 degrees, and this stays the same as 60 because nothing was done to it. Okay? And the idea, right, is that if this was all, let's say, 4, when I split this, this now became 2. That's half of it, right? So if this was x, this would be 2 times it, right? Okay. And then how can we find out this? Well, Pythagorean theorem, right? X squared, let's call it y for now. Y squared equals 2x squared. This is x squared plus y squared equals 4x squared. Subtract x squared on both sides. This gives us 3x squared. And then get rid of this square by square rooting. And so y equals square root of 3x squared. This x squared can leave the square root, so this becomes x square root of 3, right? So then, using this, all confusing, right? Using this now, for our ordered pairs, what we realize is that, again, you'll see this later in pre-calculus and beyond, right? But your book by the end of the chapter expects you to know this. So this, what we notice is for our ordered pair, this is cosine theta, and this is sine theta, okay? So x is represented by cosine, and sine here is represented by y, okay? So here, if we're talking about 30, we want this angle here, okay? This would be the opposite, this would be the hypotenuse, and this would be the adjacent. So if we're talking about cosine, my x here, for 30, this is x over 2x, right, sine 30, running out of space, and this simplifies to 1/2, right? And so here, my sine for 30 here is going to be 1/2, okay? For my cosine, that's adjacent over hypotenuse, right? So cosine, which is represented by x here. So cosine of 30 is adjacent over my hypotenuse. And this simplifies to square root of 3 over 2. Okay. So this is just the explanation, and then I'll explain to you how you can easily fill it in afterwards, okay? But this is the explanation of why this happens. It's based off of this equilateral triangle, which then creates our 30, 60, 90 triangle, okay? And so then 60 would just be the opposite, right? So 60 would be here, and so then this would be opposite, this would be adjacent, this is hypotenuse. So then you'll see that the 60-degree one is going to be the opposite. This is 1/2, and this is square root of 3 over 2. Okay, so the 45 is the other one. Okay, so how did we get the 45, 45, 90 triangle? Okay, which we learned in geometry. Okay, so 45, 45, 90 triangle. The 45, 45, 90 triangle came from a square. Came from the idea of a square. And what do we know about squares? All of the angles are right angles, and all of the sides are the same. Okay? Then, with our square, what happened is that we made a diagonal, and this is what we were left with. Okay? So we ended up splitting this into 45, 45, right? And note these are the same, right? Because part of the square, right? Side lanes are the same. Okay, it's our diagonal that's different. How do we know what our diagonal is? Well, also a 90-degree triangle, so Pythagorean theorem, x squared plus x squared is my unknown now, y squared, right? X squared plus x squared is 2x squares, okay? Then we're gonna divide. Okay, we want y by itself, right? So we're gonna get rid of the square by square rooting. So square root of 2x squared equals y, right? And then the x squared and the square root here cancel, so x is outside, square root of 2 equals y, and so this is x squared root of 2, okay? And then what we know about our 45 degrees, right, whether we do opposite, adjacent, hypotenuse, what we notice is sine of 45 and cosine of 45, since opposite and the adjacent is the same, they're both x, divided by x square root of 2 equals 1 over square root of 2. However, right, because we can't have a radical in the denominator multiply top and bottom by that square root of 2, so both of them are square root of 2 over 2. And so that's why here, this is square root of 2 over 2. Square root of 2 over 2. Okay, so how I easily memorize it for these ones, note the denominator is always over 2. Okay? Then, it's always square root of whatever, the numerator. Square root of 3, square root of 2, and technically square root of 1 is 1. Right? That makes it easy to remember. So then, I'm going to go the opposite. Since this one's 1, this is going to be 1 as well. So this is going to be 1 half, square root of 2 halves, square root of 3 halves. Then, taking it to here, it'll be square root of 3 halves, square root of 2 halves, square root of 1 half, which is 1 half. And since this one is 1 half, taking it over, 1 half, square root of 2 halves, square root of 3 halves. Right? And then same thing here, 1, 2, 3. So it's going to be the opposite, right? If this is 3, 2, 1, this is 1, 2, 3. Okay, so since this one's 3, this one's going to be square root of 3 halves, square root of 2 halves, square root of 1. Oh, sorry, don't need to write square root of 1 half. Right, so then taking that over to here, then it'll be 1 half, square root of 2 halves, square root of 3 halves. Okay, taking it over here, square root of 3 halves, square root of 2 halves, square root of 1. I didn't have to write it on. 1 half. Okay. However, right, remember what we know about each of our quadrants, right? If this was a graph, in quadrant 1, x and y are both positive. Okay. However, in quadrant 2, x is now negative, but y is positive. So that means for all of these x's, I have to add a negative to it. Eek, eek, and there you go. Right? In quadrant 3, both x is negative and y is negative. So now I have to add negatives for all these. And then in quadrant 4, x is positive, right? However, negative, y is negative. It's going down. So now I have to add all my negatives for my y, okay? And that is how I quickly do a unit circle, right? So obviously right now it wasn't very quick because I had to explain how I memorized it and how they all came to be, right? But so much of math is about meaning, right? So you need to understand why it means this, right? But then as we're filling it out, there are some tricks that can help us to do it quickly. Okay? So that's it for today. Thank you for hanging in there. Have a great rest of the day. Bye, guys.